GTA Math, what's up? So today we're about to work on a very unique interval. It's a lot of steps to it. Took me a couple hours to figure it out, but this is definitely something I feel people would benefit from. It's unlike a lot of the problems I was able to find on the internet. So yeah, let's just get straight to it. So the first thing we're gonna do is just kind of clean up what we see. So I'm gonna just rewrite this as 4x minus x squared dx. And something in factoring you learn, depending on, what you've taken algebra-wise. When you have something like a minus b, it's also another way of being written as negative b minus a. So in this case, what we have underneath this square root, we're going to actually rewrite it in this form. So we're going to have like the integral from 4 to 0. And then we're going to say it is negative, and then we're going to put x squared minus 4x. And then we're going to put dx out here. Can't forget about that. So considering what we have now, we actually got to complete the square. Not super excited about it, yeah, but we have to. So what we're going to do is take this information and we're going to use this and say, all right, we have x squared minus 4x. And since 4x is our b term, what we're going to do is say b divided by 2 squared. And since we did say this was our b term, we're going to have negative 4 divided by 2 squared, and that's going to equal 4. So right where we had this over here, this x squared minus 4x, we're going to add 4. Right? So here's what we're left with. And I do have to keep this in mind. In this step, we have a negative here. We're going to factor this negative out. And since we added 4, one thing we have to do is not forget to subtract 4. That's a very big part in completing the square. So from this step, what we're going to do is just kind of clean it up and make it look way neater, because it could use that. So we're going to have this negative in front, and we're going to divide this term by 2. So 4 divided by 2 is 2. So we're going to have x minus 2. We're going to square it. We're going to have this negative 4. And we're going to have all of this written kind of like this. And the reason why I'm choosing to write it this way is so it's a little bit cleaner to look at. And that way when we distribute this negative in, we know this is going to be negative x minus 2, and then this becomes positive 4. So we have this right here. This is what we're going to write underneath the square root. So when we rewrite this problem in this next step, I'm going to call this 1, and then this is going to be, I guess we'll call this 2. When we rewrite it, we're going to have 4, 0. Yeah, let's work together. Perfect. So we got 0 as our lower limit. Took forever to get that there. And we're going to write this function that I missed the negative on. We're going to write that into the problem. But I'm going to rewrite it this way. It's going to be like 4 minus x minus 2 squared. This looks way cleaner, and this is how we're going to put it in here. So we got 4 minus x minus 2 squared dx. Now, at the start, it doesn't look like it, but we do have a trig sub we're going to use. And the trig sub we're going to use in step 2 is going to be this one. When you have the square root of a squared minus x squared, you have a trig sub of sine. So in this top portion, I wrote it earlier up here, we're going to apply this rule that we use with sine trig subs into this problem. So what we're going to have is this. I'm going to rewrite it. I'm going to call this 2b, just so people can have like a more visual understanding of what's going on. So this is really 2 squared minus x minus 2 squared dx. But another way you could look at this is if you u-subbed this, right? You were like, yo, we're going to call this u. Then it would be more obvious to you that it's a trig sub, because then you would have 2 squared minus u squared. And now we have something that's more identical to this. But I'm lazy. I don't feel like writing out this in terms of u. So what I'm going to do is just say, scratch that, and I'm going to rewrite it as x minus 2. Matter of fact, somebody probably needs that, so I'm going to keep that there. So what I'm going to do is this. We're going to use this same identity for, not identity, but we're going to use the same formula, but we're going to apply it to this. So we have x minus 2 equals a sine theta. And our a is here. And then this is our x. So if you look at it, this x minus 2 is our x. A sine theta is going to be our 2. So we've already rewritten it. And over here, I'm going to write this triangle out because I just want to get it out the way. Here we go. Whenever you do a trig sub, you want to make a triangle just so you don't have to think as much down the line as you're putting your problem back into motion. So this, I'm going to dot it. This right here is actually going to be our original. So I'm going to put LG, I got to. This is going to be our original x equals a sine theta. And I'm putting it in this form so that way when we come back to this later in the problem, we can remember where we started off at, right? So now that we had this taken care of, the first thing I want to do is take the derivative of x minus 2 sine theta. So we got x, this is a good step 3. Take the derivative, and I'm going to make sure to rewrite this too. 4, and then 0. And then we're going to have our limit here. And what I'm going to do is this. I'm going to do a quick little side note on this side. And I'm going to say x minus 2 equals 2 sine theta. That rainbow was crazy. Was not ready for it. And from here, what I'm going to do is say the derivative of 2 sine theta is going to get us cosine. So now we're going to have 2 cosine theta, and then we're going to have d theta. And then x minus 2, we're just going to have as dx. There's a lot of things I skipped in this step, and only because I truthfully don't understand it still, even with me giving this tutorial video out. So I just want to be straightforward and honest. This part right here, still not super clear, but this is the correct step for this problem. Down the line, I'll have more clarity on it, but right now, I'm being honest. I know this is the step. I know how to do it. The why I can't really explain. So just being honest. But this is very important because when we rewrite this previous interval we had with the 2 squared minus x minus 2 squared, where there was a dx, we can actually clean it up and it's a lot nicer. So I'm going to rewrite this normally and just say 4, 0, and then just have 4 minus x minus 2 squared. In this dx value, we're going to plug this in here. So we're going to have times 2 cosine theta d theta. Cool. So now that we had that taken care of, and we have stuff in terms of theta, we got to get the rest of this in terms of theta. So we still got way more work to do. But this next step is where things can kind of get a little tricky. But I got this. Matter of fact, we got this. It's not even about me right now. So I'm going to call this step underneath the square root. I learned this from an instructor at Schoolcraft who let me utilize some of his videos and notes. And his name is Professor McCoy. And what he does is this method where underneath the square root, it's similar to saying a squared minus a squared, not a squared, excuse me, a sine theta, and then you square this, which eventually turns into a squared minus a squared sine squared theta. So this information under the square root, we're just going to rewrite it. So instead of putting a squared, we're going to actually put some numbers into it. So we're going to end up with this. We're going to have 4 minus 2 sine theta squared. If you lost, all I did was I took this information from up here and I rewrote it. Underneath the square root, this information was underneath the square root. That's all I did. So then the next step, simplify it. So now we're left with 4 minus 4 sine squared theta. And then I'm just going to factor this next step out. So then we're left with this. 4, we got 1 minus sine squared. Hopefully we all know this. If you don't, this is a trig identity. So I'm putting a different color up here for y'all. I'm going to say trig ID, because that's what this is. This is a trig identity right here. So with this trig identity, we're going to actually just say 1 minus sine squared is equivalent to cosine squared theta. So when we simplify this, we're going to end up with 4, and then we're going to have times cosine squared theta, which just equals 4 cosine squared theta. I know this is taking a while, but I really want to show all the steps because I know there's like some people that may be lost because it's a lot of math going on, right? So we're going to take this information, excuse me for zooming over, and then we're going to put this into the part of the square root we were just talking about, which is right under here. So that's going to be our step 5. So we're going to add an integral 4, 0, and then we're going to have 4 cosine squared theta times, I'm just double checking, cool, 2 cosine theta d theta. So if you hung in this far, we're probably officially like halfway through the problem. Yeah, these are some very tricky problems, especially with integrating, but we're gonna get through this. So we're on step 6, and really this is just called the cleanup step to me. Clean up. So we're gonna just simplify this this integral a little bit so it's not as gross. 4, 0, that's our limits. And the square root of 4 is 2. And just in case you don't remember this part, this is the same thing as saying the square root of 4 times the square root of cosine squared theta. This turns into 2 times cosine squared, which is what? Well, the square root of cosine squared is just cosine. So now we have this. We have 2 cosine theta times 2 cosine theta d theta. And I called it cleanup because we really just about to multiply these two things together, and then we end up with 4 cosine squared theta d theta. And I don't really like having constants inside, so I'm going to just take this 4 outside of the integral. So it's going to be like this eventually. It's going to be 4 over 0. We got a 4 here, and then we got cosine squared theta d theta. Now we can use another beautiful identity. Cosine squared theta is an identity, and I'm going to write it over here. So the trig identity for this is 1 over 2 plus 1/2 cosine 2 theta. So this is a double angle formula. I prefer to write it this way. It's a lot cleaner, it's more concise, and it's easier for me to integrate because I'd rather see 2 different fractions than one altogether. But then we're still in that cleanup step. That's why I call it cleanup, because it's like a lot going on. It's just algebra. And we end up getting here. We have 4 over 0 times 4. And then we're going to rewrite this. So we got 1/2 plus 1 over 2 cosine 2 theta d theta. And to everybody watching, we can finally integrate. It took forever. We can finally integrate this thing. So let's start chipping away at that. So now what do we have? Fortunately, we don't have a complex integration procedure we have to do because we kind of been doing it the whole problem. But this is the easier portion of the problem where it's just taking the antiderivative. So I'm going to call this step 7. And I'm just going to say antiderivative. If I spelled derivative wrong, go ahead, torch me on the internet. But I'm doing so much other stuff in this problem, I have a right to forget something. So 1/2, the integral of that is going to be 1/2. Man, I got to really get this fixed. It's 1/2 theta, and I can't forget about the limit boundaries. We got 0, and then I factored out a 4 earlier. And then the antiderivative to cosine 2 theta, it's a little tricky if you haven't been using trig integrals as much, but here's what I do, right? I leave the constant alone. So I'm going to just write this 1/2 here. I leave the constant by itself, and I do it in pieces. So I take the antiderivative of cosine, which I know is sine, and I take the derivative of this 2 theta. The derivative of 2 theta is 2, and then I flip it. So I'm going to just write a little note here so people can keep in mind. Derive, flip, and then multiply by function. And I have videos on a lot of these different steps in the problem, completing the square, integrating trig functions. So don't feel left out. There's something here for everybody. Then I got 1/2, and then we leave the inside. So then we got 2 sine, well, 2 theta, right? And then that's that part. And then just because I don't want to make another step, I'm just going to clean it up. 4, and then 0, and then we got 1/2 theta plus 1 over 4 sine 2 theta. And then now we kind kind of can evaluate it, make it look cleaner so it's not as like gross. I'm going to take this 4 and distribute. So 4 times a half, that gives us 2 theta. 4 times 1/4 just gives us sine 2 theta. So we get here, and we still have to account for our limit boundaries. But now we're kind of done with the super heavy lifting. We have to plug everything back in terms of x. So now we get to have fun. So we took the integral, and now we have to substitute all of our theta values, but in terms of x. So what I'm going to do is this. That triangle I drew earlier, we're going to go back up to it. It's like way in the beginning of the problem. We're going to take the information that we know about this trig sub, and we're going to use it. So in the beginning we said x minus 2. This is very important, so I might as well just kind of keep it. We're going to take this information and we're going to apply it down here. So I'm going to just paste it in. And what I'm going to do is solve this for sine. So I'm going to divide this 2, and then we're going to end up with this. We're going to end up with sine theta equals x minus 2 over 2. Right? So I'm going to draw that triangle again. Bam, bam, bing. Now, if we're looking at this, right, sine of theta equals x minus 2 over 2. But if we remember our trig, we know that sine theta is equivalent to opposite over hypotenuse. So this is our opposite. This is our hypotenuse. So we're going to take our hypotenuse and we're going to put it in for 2. And our opposite is x minus 2. And our adjacent value we already have. I'm not going to Pythagorean identity this because it's like not really a productive use of time. But that is going to be our 4 minus x minus 2 squared. So all of this information right here. This is our, this is our adjacent value. All of that. If you don't believe me, in your free time, go ahead and try that out. Because this problem already is a killer. And I don't feel like redoing that. So matter of fact, I'm going to not be lazy, and I'm just going to write it in. So we have I don't know why this isn't working like it should be. That's wild. This is a terrible time to not want to work. Okay, so whenever my computer starts to be human again and not annoying, we'll proceed. Did my computer like freeze? Yeah, so the next step is this. So now that we're here, we have 4 minus x minus 2 and it's squared. So with this in mind, now we can figure out a couple different things. We can figure out what a sine value is. We can say, hey, look, sine of theta equals, we already know that, so we're not going to do that one. But cosine of theta equals what? Adjacent, which is root 4 minus x minus 2 squared all over 2. I don't think we're going to need sine. I mean, not sine 10, but I think this will do for now. So let's get back to this step. So we got 2 theta plus sine 2 theta. Okay. So you're probably wondering, like, what are we supposed to do here? We have another identity, folks. Yeah, this problem is a beast, I know. So here, sine of 2 theta is the same thing as 2 sine theta cosine theta. So I'm going to rewrite this. Step 8. So we have from 4 to 0, and then we have 2 theta plus 2 sine theta cosine theta. And we have to find out what theta means, or equals. So if we look here at this equation, or this trig value, if we take inverse sine of all of this, we're going to be left with theta by itself. So I'll show the step. Sine theta equals x minus 2 over 2. When you take the inverse sine, you take it to the entire problem. So this cancels, and you're left with theta by itself equals sine inverse x minus 2 over 2. So we just figured out what sine equals. Now that we have all these little pieces, we can plug everything back into our results of our integral, but in terms of x. So here we go. We got 4 and then 0. Now we have 2 times what we just found out our theta value was, which is sine inverse and then x minus 2 over 2 plus what we just found out our sine value is. Our sine value is what? X minus 2 over 2. So we're going to plug that in. So we got 2, and we got x minus 2 over 2. And then we found out cosine. Cosine was 4 minus, almost there, x minus 2 squared over 2. Whew, man, we're almost there, guys and ladies, everybody. So now that we're here, we can finally just evaluate the integral. I know it took forever. It was crazy, but we're here. So what we're going to do is this. The old-fashioned way. We can't change the limit boundaries. We can't take a shortcut. We got to do it the old-fashioned way. But a lot of things cancel out, so it kind of works good. So we got 2 times sine inverse -1. And then we got 4 that we're going to input minus 2 over 2 plus 2. And we got 4 minus 2 over 2 times square root 4 minus x minus 2 squared over 2. And then we got all of this minus the same expression I just wrote down. Yeah, I know, this is crazy. I said the same thing when I first solved this. So we got 2 sine inverse and then we have 0 minus 2 divided by 2, and then it's plus 2, and then we got 0 minus 2 over 2, and then we got square root 4 minus 0 minus 2 squared, all of that over 2. Yeah, this is a lot, but it's cool. Like, it's Calc 2, I guess. So I'm gonna just put a 4 over here, so I know that this was all the values for 4. And then I'm gonna put a 0 over here. So these were all the values of 0. We're gonna just work slow and just, paste this out. So 2 is gonna stay. And then we have sine inverse. 4 minus 2 is 2. 2 divided by 2 is 1. So then we got a 1 here. Plus 2. And then 2 is going to stay on the outside. And then we got 4 minus 2, which is 2. 2 divided by that is 1. So not as scary as it seems, right? Then we got 4 minus, that definitely should be definitely shouldn't be a x. This is a 4. It's definitely a 4. 4 minus 2 is 2. 2 squared is 4. 4 minus 4 is 0. So look at that. When you got to deal with this thing, this is 0. So we're going to slide down a little bit, put that magic minus sign here, and then we have this other stuff. So we got 2 sine inverse, and then we have 0 minus 2, that's 0. Well, I'm losing it. 0 minus 2 is definitely -2. -2 divided by 2 is -1. So we have 2. Yeah, we got 2. We could just write it. There we go. 2, and then we got that times -1. Plus 0 minus 2 is -2. -2 divided by 2 is -1. 2 times -1 is what? Actually, make this simpler. 0 minus 2 is going to be -2. -2 squared is going to be 4. 4 minus 4 is 0. So all of this becomes 0 because you're going to have 0 times 0 times 0. As a matter of fact, we only got to do all of that. But you see the process, just in case. Lastly, we get to this step. We have to know what our inverse values of sine and cosine, tangent are still used in calculus. So trig flashbacks, big time. So we're going to just simplify stuff. And I made a big mistake. This is what happens when you do a problem too long. You start like not paying attention. This is definitely 2 and then sine inverse -1. Completely apologize about that. I'm happy I caught it though. So now that we're here, we're going to just keep simplifying stuff, right? So sine inverse of 1 is going to be pi over 2. So now we're left with 2 times pi over 2 and even this should be 0. So I really apologize. I don't know how I made all these goofy mistakes, but that should be 0 as well. So really we just had this. We got 2 sine inverse of 1 minus 2 sine inverse of 1 -1, right? That's really what we have. But I messed all of that up. But it's cool though. We're gonna keep grooving. Kind of what you do when you're that guy. You just keep moving when you make them kind of mistakes. Anyways, sine inverse of -1. Here's the trick. The boundaries for sine are pi over 2, well, negative pi over 2 to pi over 2. So you can't say you can't say 3 pi over 2. So in this case, it's going to be negative pi over 2. If the trig doesn't make sense, I have videos going over that stuff. So it's all good. But when we get to negative pi over 2, our value for this is going to be negative pi over 2. I don't know what I'm thinking, but yeah. So now we have 2 times negative pi over 2, and this becomes pi, because these two things cancel out, and then this becomes plus pi. If the algebra doesn't make sense, I'll explain. 2 times negative pi, that's going to be negative 2 pi over 2. The 2 negatives eventually cancel. These make a positive. When we simplify these two things, we end up with pi plus pi, and that makes our final answer 2 pi. I know at the end, I got like mad, drowsy, and I started making small mistakes, but this is the correct answer for the problem. I apologize for the mistakes. I'm human. I didn't expect this video to be this long either. I was like, man, this is gonna take like 8 minutes. But showing all the steps, making sure it makes sense, I'd rather spend good time doing that versus like cramming through it, because everybody's at different levels in math. And I just want to make sure I can adequately provide a solution and make sense of what's going on so people aren't overwhelmed or feel defeated. But this is a tough problem. It took me 4 hours to figure it out. So Yeah, and I didn't do well on my Trig Sub stuff in the past. So it feels good finally doing it and being confident enough to share it. But this is the answer, 2 pi. GTA Math, I appreciate you for sticking with me. Regardless of where you at in life, keep going, keep winning, push forward. But yeah, let's continue to learn, love, grow together. Take care.